Hi there, welcome to today's video. Today we'll be discussing about a very important concept in programming which is called recursion. Therefore, before jumping into the video, I would like to request everyone to subscribe to this particular channel. If you like the video, please do press the like button. It would help the video reach a much wider audience. Jumping into the video. So today I am taking a C++ example of recursion. From the main function, I am calling a helper function to calculate the power of a particular number. So I am trying to calculate the third power of a number called 3. A third power of 3, that is 3 raised to 3. That's what I'm trying to calculate. So I'm trying to calculate in a recursive manner. So once I receive the value, I will try to compute it in a recursive fashion by making the call to the same function within that function. Therefore, recursion essentially means to make a call to the same function within the function implementation. So since here we are making a call to calculate power within its implementation, this is a recursive implementation. For today, with the help of a diagram, I will try to explain how recursion works and how you will be able to get the final value in a recursive program. So let's try to visualize it, how the recursion functions. Here, from the main function, we are calling a utility function or a helper function. Let me call this particular main function as n. And from this main function, I am calling a helper function called calculate power, passing in a parameter. So I will label calculate power as CP, and I am passing 3 as a parameter to it. So this will be our first stack frame, our first call stack. I will label this as S1. This is our main call stack from the main function we are calling, right? And then from here, from when we receive the exponent value as 3, we are again calling the same function with a passing in a parameter which is 1 less than the parameter that we got. We are reducing the parameter value by 1 and calling the same function. So since we call the same function again, it will create a new stack frame. So I will label that particular stack frame as S2, and in this S2 we will be calling the same function passing in a parameter 2, and we will multiply that particular value by 3 since we are doing like this in this particular function implementation. So I will label this particular stack frame as S2. And then again, since we are receiving this calculate power of 2 as an argument, we will again call the function within the implementation since we have not yet reached the exit condition. So I will call the function again passing parameter which is 1 less than the parameter that I received. Therefore I received 2 as a parameter, and I will call 1 CP of 1 into 3. So this I would label the stack frame as S3. And since the CP of 1 will be called here, it will create a separate stack which we label it as S4. And in S4 we have reached our exit condition. Therefore we have got the parameter value as 1, and since this condition is satisfied, we are returning 3 from this particular stack frame, from the S4 stack frame. So here we got 3, and this will be returned back. Therefore this particular value will be returned back here, and this value will replace this function called CP of 1. And instead of CP of 1, we can safely assume the value as 3 since we got from the previous stack. Therefore this particular process of passing value from the previous stack frame to the caller stack frame, this is called as stack unwinding. When the stack unwinding happens, the value gets returned to the caller stack, and the caller stack can compute the final value. The final value for the S3 stack would be 3 into 3, which will be 9. Therefore, for this S3 stack, the final value which is computed is 9, and this value will be returned to the stack which called this particular stack S3. So it will be returned to the stack S2, and it will replace this particular function call to compute the final value. Therefore CP of 2 will be replaced by 9, and we can compute the final value of S2 as 27. So S2 final value will be 27, and this particular value will be returned to the caller stack. And since the caller stack function is CP of 3, this particular value will be replaced by 27, and this particular value will be returned to the main caller stack. Since there is no other multiplier here, the same value will be returned to the main stack, and the value returned will be to the main stack will be 27, and the final value printed will be value of 27. So let's run this particular program and try to see what output we are getting. Yes, we got the value as 27. So this is how the recursion functions. So once the stack unwinding happens, we can compute our final value and we can trace back to the parent stack which created all these stack frames. And to get the final value, we have to compute the final value at each stack frame. And this can be returned to the main function which called the initial function. So this is how recursion functions. I hope it was helpful. If it was helpful, please do like and subscribe to this particular channel. Thank you.